Hello everybody. In this video we're going to go through piecewise functions. Piecewise functions are just the next step of what we learned last class, which is whenever you combine multiple functions together, but with these ones, the domains don't come all together, they stay separate. And you can see that with this first example, where it says f of x equals, and then we got these three different equations, three different options. The top one says 2 absolute value of x minus 5 if x is less than 3. So that would mean that on the x-axis, when we have negative 3, something is going to happen over here, and that something is going to come from this first section of f of x. Once you get to the negative 3, that purple function is going to stop, and then it's going to pick back up with the middle function. The middle function is the negative x squared plus 4x, so we have some sort of parabola that happens. I'm just going to draw a random one. It's negative, so it's going to be upside down from negative 3 until 7. So somewhere over here we have a parabola, and if you look at the domain, it includes the negative 3, but it doesn't include the 7. I'm just imagining that that's what it would look like. Once you get to the 7, it uses the third function, the square root of 2x plus 6. Square root of 2x plus 6 is a regular square root curve, and we're going to start it at 7. So somehow it's going to end up like that. So piecewise functions are whenever you have multiple function pieces adding together to make a cool looking graph. And the rules for that graph depend on the domains that are given. And we have 3 different domains here. If you're supposed to plug into a piecewise function, it's really easy. All you got to do is look at the number that you're plugging in. We're trying to plug in a negative 5. You match it to the domain that it would go in. Negative 5 is less than negative 3, so we would use the first function. 2 absolute value, negative 5 minus 5. Close the absolute value. 2 absolute value, negative 10, which would make just 2 times 10 to be 20. So I'm going to switch to orange because we're going to use the quadratic function. Negative. When you plug in a number into a quadratic, you always put in parentheses around the number you're plugging in. So we put the negative sign first, then the 2 parentheses squared plus 4 times 2. You square the 2 first to get a 4, but don't forget about the negative sign in front of it, then add 8. Negative 4 plus 8 is 4. For the last part, it's directly at 7, which is at the boundary. So let's just make sure. If we are including the 7, that's going to be the square root function. So I'll switch to that color. Square root of 2 times 7 is 14 plus 6, square root of 20. In this g of x one, we have 3 different functions again, but this time we have a constant function. So between negative 4 and negative 2, negative 4 until negative 2, it's just going to be straight at the number 8. So imagine up here is 8. We're not going to include that 8. We're not going to include the 8 at the negative 2 either. But between there, we're just going to be a constant 8. Before that part of the graph, we have 1/2 x cubed plus 7. So that means we're going to have some sort of cubic, which means it's going to be, normally a cubic goes through the origin with that sort of shape. But since there's that plus 7, and since we're over in the negatives less than 4, I'm just going to imagine it's going to be like that. Something like this is going to happen on the graph. For the final part of the function, this step function, let me see if Desmos has the right tool for that one. X minus 4 inside of a step function. So let's write y equals And then I believe this floor one will do it for us. X minus 4. Yeah. Whenever you have that double bracket around that x minus 4, that means you're going to have an interval or a staircase, or sometimes called a floor graph. That means it's going to round the numbers to the nearest integer. That's not the important part right now. Right now, we're just trying to plug in these numbers. So let's finish doing that. G of negative 3 means we're going to plug in negative 3. And negative 3 is greater than negative 4, so we're not going to use the cubic part. Negative 3 is between negative 4 and negative 2, which means I'll use the green. And it says if we're between negative 4 and negative 2, which negative 3 is, then the answer is just 8. For g of negative 8, we're going to plug in negative 8, which is less than negative 4, which means we are part of the cubic function. So I'll do 1/2 negative 8 cubed plus 7. Negative 8 cubed would be the same thing as 64 times 8. I'm going to guess that it's 512, but I'll check with Desmos. 8 cubed is 512. So half of 512 is 256. When you cube a negative number, it stays negative, so we'll put negative 256 plus 7, and we get negative 249. For the 3.1, this is greater than negative 2, so I'll use the last part of the function. This weird symbol, and then plug in 3.1 minus 4, then the weird symbol. Subtract them, it's a negative 0.9. And what the symbol means is round it to the nearest integer. So when we round the negative 0.9, it'll round to negative 1. And that's the end of that one.